Hi, in this video I'll demonstrate the data processing skills that you need for IB. So whenever you do an IA or a physics exploration, you need to design your experiment in such a way that after collecting the raw data, you process it and plot a graph such that you get a linear graph, and from the slope you would need to calculate some physically relevant information. So to demonstrate this, I have collected here the raw data for a simple pendulum experiment. So the theory behind this experiment, let me quickly explain. So suppose this is the simple pendulum. It's just a mass hanging from a thread, and it will oscillate if you release it after displacing it from its mean position. So let us say we are interested in finding how the time period varies with the length of the simple pendulum. Length is the length between the point of suspension and the center of mass of the bob. So theoretically you can derive the relation. It would be time period is 2 pi into root of L by G. So when you are doing the physics exploration, once you choose your dependent variable and independent variable, you have to derive such a relation on your own. And then just as we are going to verify this experimentally, you also have to verify your derived relation experimentally. So even for your extended essay, this is the same approach you need to follow. So now suppose when you derive the relation between your dependent and independent variable, so here this is the dependent variable, this is the independent variable. So you need to draw a straight line graph to verify this relation. So if you directly plotted time period versus L, that is dependent versus independent, you wouldn't get a straight line graph, you would get a root function. For example, let's just type that root function and see how it is. So x to the power 0.5, let us graph it. So it would be like this. So x here would represent the length and the y here would represent the time period. So you would not get a straight line graph, it would be a curved graph like this. So you can't really find out what is the exact way it is related. For example, suppose instead of x power 0.5 it had been some 2 times x power 0.5. The graph would be different like this, as shown by the green graph. So you wouldn't have any way to find out that the coefficient of x power 0.5 is 2. So if it had been 1, it would have been this black curve. If it is 2, it is this. So there is no way to find out the coefficient just by looking at this graph. That's why we prefer to convert your data in such a way that you can plot a straight line graph. Because if you have a straight line graph, it would be of the form y is equal to mx plus c. So a linear graph would be obtained if your function is of the form y is equal to mx plus c, where m is the slope and c is the y-intercept. So if we can convert this equation into this form, so what we can do is we can square both sides, or we can directly plot time period versus root L. So or the other option is square both sides, so you get t squared is equal to 4 pi squared by g into L. So now t squared would correspond to y, the slope would be 4 pi squared by g, and L would be x, and 0 would be the y-intercept. So the graph for this kind of function would be since the y-intercept is 0, it should pass through the origin, and since the slope is a positive number, it should be having a positive slope. And when we plot a straight line graph, we can easily calculate the slope of the graph, and by equating the slope to 4 pi squared by g, we can find out the value of g. So we have found a physically meaningful quantity, which is the gravitational field at the surface of the earth, just by plotting a straight line graph and finding the slope. So this is the idea behind every investigation you do in physics. When you plot a straight line graph, from the slope you can extract some meaningful information. Okay, so when you calculate g, you are supposed to report that also with the uncertainty. So that's why you need to calculate the maximum and minimum value of the slope. So our goal would be to find delta g. What we would do is, delta g is the error in g, it would be g max minus g min by 2, where g max is the maximum possible value of g, which you can get by using the slope values. So g max would be 4 pi squared by the minimum possible value of slope. So let's call it S min, and g min would be 4 pi squared by S max, the maximum possible value of slope. So now I'll show you how to calculate the maximum value of slope, minimum value of slope, and using that we can find the maximum and minimum value of the gravitational field. Using that we'll report our gravitational field value with the uncertainty. Okay, so let's go to the spreadsheet. So what you do is, you vary the value of the independent variable, and here we have taken 9 values. So you have to make sure the range of your independent variable values is quite comprehensive. That is, it should capture the variation of the dependent variable effectively. So I started with as large a value of length, which is 1.65 meters, to as small as possible, which is around 11 centimeters. And you should take enough number of trials. I recommend a minimum of 3 trials. See, you decide how many trials you need based on the variation in the dependent variable values which you measure. So suppose the variation is very less, 3 trials is enough. But if the variation is too much, it's better to take at least 5 trials. Okay, and then you take the mean of those 3 trials. So when you record the data, make sure the number of decimal places are same in a particular column, in each column. You can't have 51.91, then 48.8, then 46, then 42.350. So that's just not accepted. So when you take a measurement, the instrument will have a certain precision. So in this case, the stopwatch records time up to a precision of 2 decimal places. So all the time values should be reported to 2 decimal places. And here the length is measured using a meter scale. So the least count is 0.1 centimeters. So all the length values should be reported to 0.1 centimeters. So now to take the mean, all you need to do is, so I'll just delete the values and show you how I did it. You can just type average. So equal to AV, if you type, you will get the average function. Double click it and then select these cells. Then close the bracket by going to the formula bar and press enter. So once you get the first average value, copy that formula, click on the lower cell, select all the cells and do Ctrl V. For copying you do Ctrl C. So this will automatically change the formula and enter it in the respective cells. So now that you have found the mean value of the total time taken for 20 oscillations, which I am calling it as T20, so you need to know how to write these subscripts also. You can't leave it as just T 20 like this. So to write it in the form of subscripts, just select the text and then keep the pointer over it, right click, format cells, then select superscript and OK. Oh sorry, I have to do subscript. So format cells, select subscript and OK. So that's how you do it. And for errors in the quantities, use delta. Delta refers to change in the quantity or the error here. So the way to enter delta is click on insert menu, symbol, and select the delta. If you can't find it in the recently used symbols, select the subset as basic Latin and font as Calibri, you will find it. So insert, close. So now the error is see, you can follow this method for finding the error in any quantity which you have measured or calculated. The method is find the maximum minus minimum and divide it by 2. So here the formula I would type is equal to, if I select max function, double click it, it will select the maximum value out of these 3 cells, that is the 3 trials, and close the bracket, minus, now select the minimum value, so minimum function, again select these 3 trial values, close the bracket. Now this whole thing you have to divide by 2, so put this entire function inside a bracket and now divide it by 2, then press enter. So just copy and paste it in the remaining cells, you will get the values for the corresponding cells. So now you know the error in the time taken for 20 oscillations. So now you need to measure the time, you need to calculate the time period. So time period would be the total time taken for 20 oscillations divided by 20. So it's just total time is the mean time here, so is equal to the mean time for 20 oscillations divided by 20. Press enter. Again copy and paste this formula in the remaining cells. Now the rule for error calculations what we have used, let me explain here. See here, so according to the IB, if you have say y plus or minus delta y, if you are going to multiply or divide this by a constant, you have to do it for the error also, the absolute error also. So for example, if I am going to divide it by 20, if I am going to divide y by 20, I should also divide the absolute error by 20. The justification for this is, when you have a measurement with a certain relative error, if you multiply or divide it by a constant, the relative error should not change. So if I do like this, so let us say this is some p, okay, let us say p is, or okay, so the relative error for this original number was delta y by y. So now if I have a new quantity which is the old quantity divided by 20, so let us call it p, then the error in p would be the relative error in p would be delta p by p, which should be delta y by 20 divided by y by 20, which would again be delta y by y. So the relative error does not change provided you divide the absolute error in that quantity by the same number which you are dividing for the actual quantity. So applying it in our case, we got time period is the total time taken for 20 oscillations divided by 20. So delta t, error in time period, would be error in the time taken for 20 oscillations divided by 20. So that's what we are doing here in the spreadsheet. So error in time period is is equal to error in the time taken for 20 oscillations divided by 20. Okay, so now this is having lot of decimal values. So in IB, all the errors which you have should be rounded off to one significant figure, because it's meaningless to talk about the second decimal or extra decimal values. If there is an error in 0.01 itself, in the first digit itself, what's the point in talking about the higher decimal values? So we'll round these two numbers to 2 decimal values. So just select them. So what I did is, so let me do it and show you. I'll delete it for you now. Just copy this, Control C, click here, right click. Now select paste special and values. So what this does is it just copies the values, the numerical values, and it doesn't copy the formulae. So if you don't do this, it will copy along with the formula, and the formula will adjust itself to the new position, and you will get some different values. So you just want the numbers here. So select values and select OK. So now right click and go to format cells, select number and select the required number of decimal places. So I need 2, so select 2. So it will round off to 2 decimal values. Since I had already done that formatting, it's showing already formatted. Otherwise it should have shown you up to 4 decimal values. Similarly, select these remaining cells and round them off to 3 decimal values, since that is when they will have the one significant figure. Next, for plotting the graph, you need time period squared. So this would be just is equal to the time period which you had calculated to the power 2. So copy and paste the formula in the remaining cells, you will get time period squared. Now for finding the error in time period squared, we will follow this second method, which will work for all cases. It's again just the maximum possible value of this quantity minus minimum possible value of this quantity divided by 2. So if you are finding time period squared, the error in that, first find the maximum value of time period squared. So let me explain how to do that. So let us say y is equal to time period squared. So you want to find delta y. So delta y would be the maximum value of time period squared minus the minimum value of time period squared divided by 2. So now how would you find the maximum value of time period squared? You would get it by substituting the maximum value of time period inside this and then squaring it. So time period, maximum value of time period, how would you find? It would be, you have to add the absolute error in it. So time period plus the error in time period, the whole squared, and the minimum value of time period squared would be time period minus the error in time period the whole squared. So substitute that here and you can calculate the error in time period squared. So that's what we have done in this spreadsheet. So the maximum value of time period squared is equal to, you open bracket, first find where is the time period, it's here, plus the error in time period rounded off to one significant figure is here, and you have to square it. So then copy and paste it in the remaining cells. Similarly, for the minimum value of time period squared, put equal to open bracket, select the time period, then subtract minus the error in time period rounded off to one significant figure, and then square it. Then copy and paste it in the remaining cells. So now error in time period square would be this max minus min by 2. So is equal to this max minus this min, put them inside a bracket and divide by 2. So copy and paste it in the remaining cells. Then the next step is to round off this error to one significant figure. So as explained before, you do it. So now here you would find that for this last value it is showing 0.00. So I told you about the rule that in a particular column all the values should be of same number of decimal places. So there's no point in showing it up to one more decimal place here. So you can just consider that the error is negligible compared to the errors in the other quantities. So let it be 0 itself. So now we are ready to plot the graph. So first we'll plot the graph for time period versus length. Okay, so let me create some more space here, or I'll do it below itself. So first copy the independent variable, Control C, let me scroll down. Now right click, paste special, values. Next copy the dependent variable, which is time period. Right click, paste special, values. Okay. Next note down the error in the independent and error in the dependent variable. So error in independent variable would be just one decimal value for all. So let me round it off to one decimal. Right click, format cells, number, one decimal. And the error in time period, let me copy it. So this is the error in time period rounded off to one significant figure. Control C. Right click, paste special, values. Okay. Now let me round it off again here. For these I'll round off to 3 decimal values. As I mentioned, if you apply the rule that all should be of same decimal values, then these values would have almost zero error. So you can do that if you want. So now let me plot the graph. Select the data cells of the independent and dependent variables. Oh wait, now before that let me round off the time period also to the same number of decimals as the errors in them. So these two I'll round off to 2 decimal values. And the remaining I'll round off to 3 decimal values. So when you report these tables in your report, so make sure you copy this table and paste it in the Word document. So before doing that, so format it properly like this. Okay, so now select these values, go to insert, scatter, and scatter with only markers. So you see, just as I had predicted, you have got a curved graph instead of a straight line graph. See, so this is similar to the root x function. So if you had just so using this, it's difficult to find out the actual equation, but actually in spreadsheet you can use it. See, okay, before we proceed further, let's put the titles. So make it a habit. So click on under chart tools, layout, chart title, above chart. So the title would be time period versus length, and then put the axis titles, primary horizontal axis title, title below axis. This is length of pendulum L/centimeter, and for vertical axis, under axis titles, primary vertical axis, rotated title, it's time period T/seconds. So now we need to fit the data points. So click on trend line, more trend line options. So now if you see, if I had selected the linear trend line by default, select display equation on chart, display r squared value on chart. So you see the r squared value is 0.97, so it's not such a good fit. And you can also see that the points are clearly on a curve and not on a straight line. So instead, let's select the power. Now you see that the r squared value is exactly equal to 1. That means whatever equation the spreadsheet is giving me, it's exactly fitting the data points. So this would be the best way to select it. So now click on close. Now copy this equation and drag it and put it in this area so that you can clearly see it. So now if you analyze this equation, the coefficient is 0.2026 and the power is almost 0.5, which means it's root x. So you can see that it's automatically telling me that if I had plotted time period versus root x, I should get a straight line. So that's what we will do in the next step. So instead of plotting time period versus root x, you can also plot time period squared versus x or L. So that's what we will do here. So I have copied the length and I have copied the time period squared, and I have again copied the error in time period squared. So like before, select all the data points and plot the now this time select linear. Okay, I'll do it for you. Okay, so now select the data points, insert, scatter, scatter. So you see you get a perfect straight line graph. Now put all the titles, layout, chart title, above chart. So this time it is T squared versus L. So again in the title also don't forget the superscript. So right click. Okay, you have to right click in the inside the chart. So right click, font, superscript. Okay, now put the horizontal and vertical axis titles also. Primary horizontal axis, title below axis. Length. So always remember to describe the variable symbol, space slash unit of the variable. Similarly, vertical axis title, rotated title, t squared in second squared. Press enter. Now make it superscript. Okay, again here also. Okay, so now we are ready to fit the line. So go to trend line, more trend line options, and select linear, which is by default. Display equation on chart, display r squared value on chart. Now you want to show that the graph clearly passes through the origin, so use this forecast option. If you want the graph to go forward along x-axis, put some numbers forward so that it will go that many units forward. If you want to extrapolate it backwards along x-axis, put that many units backwards. So here it's around 10, so let me put 10 units backward and see what happens. Click on the other cell, so it almost passes through the origin now. So we'll leave it at that. Click on close. So this is your equation for the straight line. Put it here where you can see it clearly. So now you see y is equal to mx plus c. C is almost 0 and r square is practically 1, which means it's a very good fit. Now you need to put the error bars in this. So to put the error bars, go to here under layout, you have error bars option and more error bar options. Now by default it is selecting vertical error bars, so we have varying errors for each data point. So let's select custom, specify value. Okay, before you do that, move this pop-up window here so that you can see the values which you are going to enter for the error bars. Now click on specify value, click on this button for positive errors and select all the errors. So these are the errors in my y-axis, which is t squared. So again click the button. Now for a negative error bar also it's the same values, so again I select the same values. So click on this and say OK. In some computers by default it would have selected horizontal error bar, so in that case you have to put the value for the horizontal error bars. Okay, so now this is done, so I'll click on close. So you can see the error bars. So in this particular experiment the error bars are very small, so you can hardly see them, but it's correct only. So I'll just prove it. If I instead of 0.05 if I type 2, you can see that the error bar has changed here. So our error bars are correctly plotted, that means. So now let's put the horizontal error bars also. So again click on layout. You see here on the top left corner a drop down list called chart area. So click on that and select series 1x error bars. Now go to trend line, more options. It will by default have selected horizontal error bars. Oh sorry, not trend line, we need to go to error bars. So go to error bars, more error bar options, and by okay, wait, again I have to select series 1x error bars. Now if I go to error bars, more error bar options, by default it has now selected horizontal error bars. This time I will leave it at fixed value and my fixed error is 0.1. So now close. Okay, since I selected the trend line by mistake, it has changed the y value. So let me again set the y values correctly. Or I need to, okay, I'll just remove all the trend lines first. I'll just do it fresh. More trend line options, linear, display equation, backward, 10, close. Now the error bars, more error bar options, custom, it's vertical error, specify value, then the error negative error value is also same cells. Okay, close. Now I'll select the horizontal error bars, series 1 X error bars. Again go to error bars, more error bar options, fixed value I'll make it 0.1, close. So this is the correct ones. Okay, so now we need to draw the max. Now we need to draw this graph with maximum slope and minimum slope. So for that, let me explain the concept. So suppose this is the y-axis, this is the x-axis, and I have a straight line graph like this, and these are my data points, and the error bars are like this. Okay, so now I want to, now this is the default slope for the best fit line, so let us call it S. Now I want to find what is the best fit line which I can draw with maximum possible slope. So let me draw it in red. By convention for max slope I will draw it in red. So I have to draw a straight line passing through these 2 points. So then it would automatically have the maximum possible slope which would lie within most of the error bars of my data points. And to draw the line with minimum slope, I would draw a straight line connecting these 2 points which I am showing in blue. Again it would pass through most of the error bars and it will have the minimum possible slope. Now suppose I called this particular data point coordinates as x1 comma y1, and I called this particular data point coordinates as x2 comma y2. And let the error bars be delta y, error in vertical error bars be delta y. Then the coordinates for this particular point would be, let me write it in red. So this would have the coordinates of this x2 would be still the same, x2 comma y2 plus delta y it would become, because it's greater than y2 by the amount of the error. And this coordinate, the coordinate of that point would be x2 comma y2 minus delta y. Similarly, the coordinate of this would be x1 comma y1 plus delta y, and the coordinate of this point would be x1 comma y1 minus delta y. So now to find the slope, what the spreadsheet did was it just found out y2 minus y1 divided by x2 minus x1, which is basically rise by run, right? This vertical distance divided by this horizontal distance. Now to find the maximum slope, we will do again rise by run for this red line. So it would be y2 plus delta y minus y1 minus delta y divided by x2 minus x1. And for this minimum slope, it would be the rise by run for this blue line, which is y2 minus delta y. Let me write it in blue. Minus y1 minus delta y. No, this would be, sorry, here, yeah, this point would be y1 plus delta y. Divided by x2 minus x1. So if you actually simplified, S min would be y2 minus y1 minus 2 delta y divided by x2 minus x1. And the maximum slope would be, let me write it in red, y2 minus y1 here minus of minus would become plus, so it will be plus 2 delta y divided by x2 minus x1. So as you can see, the denominator is same, but the numerator for S min is less by 2 delta y, whereas the numerator for S max is more by 2 delta y. So naturally S max would be greater than S min. So this is what we are going to do in the spreadsheet. So I first pick my data points carefully. So for the rightmost point, I am picking 150.9 instead of 165.9 because it has a bigger value of the error. So my delta y would be bigger. And for the leftmost point, I am picking 30.9 instead of 10.9 because 10.9 doesn't have any zero error. So I want the error bars to be as big as possible. So I have picked 30.9 comma 1.26 and 150.9 comma 6.05 as my x1 comma y1 and x2 comma y2. So now you can calculate. So x1 and x2 are going to be same for max slope as well as min slope. So it's the same thing. I just typed here is equal to and I clicked on this cell. So is equal to, click on this cell and press enter, you will get it. Similarly is equal to, click on this cell, you will get that value. Now for max slope, so I have to do as per the formula we derived. This higher this point, the y coordinate should be y2 plus delta y, right? So if you see the formula, this is x comma, okay, this is the lower point here. So this should be y2 plus delta y. So the y2 is 6.05, which is C22 cell, plus delta y is D22. Similarly for this one, it is for maximum slope you want this point to be as lower as possible, so it should be y1 minus delta y So if you click here, y1 is C28, which is 1.26, minus delta y is D22, and here it is D28, this cell. Clear? So now you need to select these cells and plot it here. So for that, right click on this graph. You have this option of select data, click on that, and then click on add series. So here already series 1 is there, so now click on add series. Type the series name as max slope. Now for selecting the values, click on that, select that X, and then scroll down and select the X values. Click on the button again. Now select the series Y values by clicking on this button and select those two cells, and again click on this button. Now do OK. So similarly you can calculate the min slope values and add the series here for them also. So click again on add. Type the series name as min slope. So series X values, select these two X values. For series Y values, click on that button and select these Y values. Select OK. Then click on OK. So now you find that the red dots represent the coordinates for the max slope line, and the green triangles represent the coordinates for the min slope line. So now you need to join them by the straight line. So go to layout, under chart tools, click on the drop down list for chart area and select series max slope. Then go to trend line, more trend line options, and select linear display equation on chart. Then make it red colored by selecting line color, solid line, and select red and close. So now you can see the red line has appeared. You can also extrapolate it forward and backward. So just remember to do that. So let's extrapolate it by say 30 units backwards. Yeah, that's fine, it has extended till the origin. Forward also let's extend it by some 30 units. Okay, it's fine. Now close. Now drag and drop this equation here and change the label and put it as max slope so that you don't get confused. So as you can see, the slope of this equation is greater than 0.0402. Similarly, now select here series min slope and go to trend line, more options, select linear display equation on chart. We are not selecting display r squared value because it will be anyway 1, because any function will pass through the 2 points. So now make it go backward and forward, say 30 units. Now click on close. So since the error bars are very less, the variation in the slope is also very less. Again label it as min slope. So that completes your graph. So now you note down the values of max slope and min slope from the graph and put it here. Then you can calculate the G and the error in G. So error in slope is again max minus min by 2. So max slope, this cell, minus min slope by 2. And G value you can calculate as 4 pi squared divided by this particular slope, which is E38, this one. So G max is 4 pi squared divided by min slope, which is this value. And G min is 4 pi squared divided by max slope, which is this value. So now the error in G is max slope minus min slope by 2. This max slope minus min slope by 2. Now you have to round off the error to one significant figure. So you will round off 17.259 etc. as 20, because 20 has only one significant figure. So G value also you have to report according to the significant figures in the error. So you will have to round it off to 980. So then it has two significant figures. So the final answer would be reported as 980 plus or minus 20 centimeter per second squared, or 9.8 plus or minus 0.2 meter per second squared. So that concludes the demonstration of the data processing skills.